This is the topic 5 video for notes on parallel and perpendicular lines. This goes along with page 24 in your chapter 4 packets. So parallel and perpendicular lines are two special pairs of lines. We'll start with parallel. Parallel lines have equal slopes. So what this means is if they both have the same slope and they're different y-intercepts, because they have to be different lines, they are never going to intersect. They're going to stay equidistant apart forever and ever and ever, and they will never get closer together, they will never get further together. So even though I don't have a grid on this little sketch I did, I can tell that they both have the same slope, they're both rising and running the same amount because they never get closer together and they never get further apart. So if I look at my first example, find the slope of the line that's parallel to the given line. All right, well, this one's nice because it's in slope-intercept form, so I know the slope of the line that they gave me is 2. All right, so if parallel lines have equal slopes, a parallel line slope is also going to be 2. Looking at number 2, this one is in standard form, so we do have to get this one to look like slope-intercept form. So that means we are going to need to start by subtracting 3x from both sides and then dividing everything by 6. So I end up with y equals, reduce the fraction, negative 1/2 x plus 2/3. Now, it didn't say put the line in slope-intercept form. It says find the slope of the line that's parallel. So the slope of this line is negative 1/2. So the slope of a parallel line also has to be negative 1/2. Number 3 is similar to number 2. It's actually not in standard form because x can't be negative. It's in a form that we don't like. So I do know to get it into slope-intercept form like number 1 and like we did with number 2, I need to get the x term to the other side, so I'm going to move it by adding it. I get y by itself, which is nice because now I'm done converting it to slope-intercept form. What's the slope? 2, so a parallel slope is 2. Now we're going to look at perpendicular lines, which are a little bit different, and they have these two I call them fancy words, they're really not that fancy. Perpendicular lines have slopes that are opposite reciprocals. So the word opposite means we need to change the sign. So if it's positive, it's now negative. If it's negative, it changes to positive. Reciprocals means flip the fraction. All right, so if we have 2/3, our reciprocal would be 3/2. So in order to find a perpendicular slope, we have to do both these things. Change the sign, flip the fraction. So the examples for these three are the same lines, they're the same equations, but now we're just gonna look at making it the opposite reciprocal. So if the slope of number 1, oh, sorry, I forgot I drew a graph. What does this look like? This means that the two lines intersect at a 90-degree angle. All right, so that's why perpendicular lines are special. They're not just intersecting, they're intersecting at a nice 90-degree angle. All right, now we'll talk about number 1. So the slope of this line is 2. So if I think about what I need to do, all right, I start with 2. I'm going to make it 2/1. That way I can see where and how I'm going to flip the fraction, because 2 is not a fraction, but we can always make it 1 by putting it over 1. So if I change the sign, it will now be negative since it was positive, and if I flip the fraction, it's 1/2. That would be my perpendicular slope. All right, number 2, we already did all the hard work to get this into y equals mx plus b form, so I'm just going to copy it from the previous page, or previous slide. So if I have negative 1/2, that's the slope of number 2. I need to change the sign, and I need to flip the fraction, so it then becomes positive, and then 1/2 flips to 2/1. Now I'm going to reduce it because plus 2/1 looks kind of weird. That's just regular 2. All right, number 3, again, we've already done this problem. Y equals mx plus b form, we take 2, and unfortunately it's the same as number 1. So 2, put it over 1 so we can see what we're flipping, make it negative, and flip the fraction. All right, so perpendicular lines, change the sign, flip the fraction. Parallel lines, equal slopes. So I would like you guys to do these 4 U-tries on your own. Numbers 1 and 2, you are going to be finding a parallel slope, and 3 and 4, you're doing a perpendicular slope. I'll post solutions to this after you watch the video. No, seriously, pause and do them right now. All right, writing the equation for the line that passes through a given point and is parallel to another line. This kind of sounds like a lot of information, but let's break it down into 3 steps. So first step is going to be find the slope of the given line. Parallel slopes have the same slope. Sometimes we might need to change it to y equals mx plus b first. All right, if it's in standard form, we can't see what the slope is. All right, number 2, use that equal slope. And given point, put it in point slope form. Again, parallel lines have the same slope. So whatever line they give us, our new line is going to have that same slope. And because we're given a point, we have to do point slope form first because we might not be always given an intercept. And then our last step would be change to slope intercept form or standard form depending on what the question asks. So for the next 2 examples, it does ask for slope intercept form, so that's nice. No more standard form for a while. So write the slope intercept form of an equation of a line that passes through the given point and is parallel to the graph. So I wrote in that the slope of the given graph is 1, or 1 over 1. So that means an equal slope would also be 1 because parallel lines have equal slopes. It goes through the point 5, 1. We can see that in the picture. So I'm given a slope and a point, so I have to put it in point slope form first. Now the question does ask for slope intercept form, which is y equals mx plus b. So we're going to distribute and get y by itself. So y equals x minus 4 would be the equation of our new line. So again, it's going to go through that point 5, 1, but have the same slope as the line that's shown. Number 2, we're going to have to do a little bit more work for this one, only because the line they gave us is in standard form. All right, so we're going to change that to slope intercept form. So we're going to start by subtracting 4x from both sides and dividing everything by -3. So we end up with the equation of this line is y equals 4/3 x plus 4. The only thing we need from this line is the slope. So the slope is parallel, so it's the same, and it goes through that point -3, +3. Now it's going to be more like problem number 1. We have a point and a slope, put it in point slope form. Now distribute and get y by itself. So our final answer, y equals 4/3 x plus 7. So again, if I asked you for point slope form, we would be able to stop all these at the black writing. But because it asks for slope intercept form, we need to convert from point slope to slope intercept, and we've had a lot of practice with that. Right now, I would like you to do this you try, please. So pause the video and do this one just like we did the previous 2 problems. All right, last note slide, we're going to write the equation for a line that passes through a given point and is perpendicular to another line. So it's just like the previous 2 note slide problems, except instead of using a parallel slope, we're going to use a perpendicular slope. So step 1 is the same. Find the slope of the given line, but we need to change it to the opposite reciprocal because of perpendicular. All right, we can't just copy the same slope. That would be parallel. We need the opposite reciprocal for perpendicular. All right, put it in point slope form and then change to given form. So whatever form the question asks you to do. All right, so first example, we've got our line, -1/2 x minus 4, and it needs to go through -8, 7. So first, I need to take the slope and make it the opposite reciprocal. So if I flip it and change the sign, it's going to be positive 2 over 1, which is 2. All right, and then it goes through -8, 7. Point slope form time. It does ask once again for slope intercept form, so distribute and get y by itself. So the equation of a perpendicular line would be 2x plus 23. Now, we can't graph this on the grid because 23 is a big y-intercept. It's way too off the grid. But if we were, the 2 lines would form a 90-degree angle at the point of intersection. All right, our next one, we've got the same line as the second problem on the parallel one, so I'm going to save some time and just write it because we already did all the work. So we had our slope was 4/3. Now, because we need to make it perpendicular, change the sign and flip the fraction. So we're actually going to be using the slope -3 over 4 and the point -3, 3, put it in point slope form. All right, now when we distribute the slope for this one, it's not going to be as nice because we're going to have fractions, but that's okay. Negative 3/4 times 3 is negative 9/4. When we go to add 3 to both sides, we know that we don't have common denominator. So I'm going to change negative 3 to negative 12/4. That way I can add them. Add 12/4 to both sides, and we get our final answer, negative 3/4 x plus 3/4. All right, the last thing I'm going to ask you to do today is this you-try problem. So they give you the equation of the line and the point. Make sure you use a perpendicular slope. And that is the last thing you're going to do. Thank you for listening.